So doing a little bit of review work of the graphing, okay? So graphing rules, there are a couple of things that I do need you to do. So that means when I assign anything that is a graphing assignment, you're expected to um, follow these rules. You probably need your own paper, okay? We'll discuss that when we get to it. You have to use a ruler and a pencil. You must have a name, date, and also title on it. I would suggest you put it on the top, like at the top of it, and I will look for it. Even if you do 3 graphs, you still need to do it for every single graph. You have to label your axes with the units, and scale has to be uniformly number and spacing. And your scale should be large enough so that your graph will cover most of the paper. If you have a full sheet of paper and you do a graph, don't make your, like, if your graph only goes up to 10, don't make your axis goes up to 50 or something like that. You want it so that your axis is scaled to the point that it covers most of the page, at least half of your piece of paper. And the other thing you need to watch out for are your axes have to be uniform. Okay, if every grid is 2, then you go 2, 4, 6, 8, 10. If every scale is 5, then you go 5, 10, 15, 20. You wouldn't actually use the number of your point to be the axes, and you also don't want to go up in like weird increments like 3.54 or something like that. You just make it easy for yourself, okay? All right, and then you need to clearly mark the dots, and then you have to draw in a line of best fit. Okay, you always use a sharp pencil when you're plotting your points. And then the other thing I want to talk about are the slope. Okay, you are expected to be able to do 2 things. We call these the graphical analysis, because when we get to speed and velocity, there are actually ways that you can do graphs. So graphical analysis, what you need to do is you have to know how to find the slope. That's the first thing. Okay. Oh, actually, I lied. Graphical analysis, sometimes you need to know how to read value of a graph, right? So you just go X and Y and you read it. You also need to know how to find the slope. Another way to do slope is that we use the symbol M is y2 minus y1 over x2 minus x1. Okay, so if I'm just going to put in values. I would like you to write it out too. Okay, so imagine if this is a 2 and this is a 5. I'm just making numbers up. And then this is a 1 and this is a 4. Okay, they're equal increment 2, 3, 4, 2, 5, 6. I don't know, I'm just making this up. Okay, so your x1, y1. So the first point is the point that is to the left. This is your first point. Okay, so that means the x1 is 2. y1, what is the y? Like the x is y, and then the y is the 1. And then the second point is up there. Sorry, I'm just going to change the color. Second point is up there. And this is point 2. Point 2 is at 5. We go x, we go sideways first, and then we go up. That's 4. So to plug it into the equation, y2 in this question is going to be 4 minus y1, which is 1, divided by x2, which is 5, minus x1, which is 2. So I find that it's easy if you label them on the graph. I don't know if you need me to label what they are. So this is your x2, y2. And this is your x1, y1. Okay, just to reinforce, to make sure we're good with, like if this is 0, 1, 2, 3, this is 0, 1, 2, 3. If I have a point right here, okay, if this is the point, okay, this axis is the x-axis and this axis is the y-axis, and I ask you what is the coordinates of this, I write x first. So along x, I'm going sideways this way. So 1, 2, this is 2. So x1, x is 2. And then how much does it go up along the y? It matches up with the 1. So this is 2 and 1. Okay, back to the slope calculation. 4 minus 1 is 3. 5 minus 2 is also 3. 3 divided by 3, the slope of this line is 1. Okay, the other analysis that we will be asking you to do is calculate the area under the graph. okay? And when I have a graph, this is a graph line. This is the graph. The area under the line means I go from, you know how this is the 0 axis? I basically block it off and find the area under this curve, okay? And this is a triangle. So area in this particular case is a triangle. The equation for triangle is 1/2 base times height. And then I would literally read from the graph, okay? Say if I'm making these up, okay? The base is at the bottom. This is my base, okay? This is my base. So 1/2 base, which is 5, because it goes from 0 to 5, to the height. The height is from wherever this is 10, so the height is 10, so 1/2 times 5 times 10, that gives me 25. Okay, so that's the other thing you would be required to. And then some basic rules on how to do graphs, just do it properly. Okay, first one. Okay, so the left-hand side graphs are a good example and a right-hand side graph is a bad example, and they're asking you to pick out why is it a good or a bad graph. So the first one tells you this graph is distance versus time graph. Okay, distance versus time graph. And then this one tells you is time versus distance graph, and they're telling you this is wrong. The reason for that, I need you to write it somewhere on your page. I don't know if I left you enough room at the side or something like that. You can write it in the middle if you want. Okay, science graph, the title is always y versus x graph. Next one. Okay, next one. The left hand side is good, the right hand side is not good. The first thing is make sure you use a ruler. Okay, the other thing is this person probably used a pen. Please use a pencil and you would erase any mistakes. Okay, next one. I got a whole bunch of numbers here. And do you see how there are a problem with the axes? Okay, you see how like there's 10 to 20 is this big, but then 20 to 30 is this big, right? So the rule is for the axes, you have to have equal increment. Meaning you go up the same number with the same amount of space between them. Okay, this one, I have no idea. Maybe the dots are nice and clear. So nice clear dot. Make it bigger and clear. If you go like book and I can't see it, I assume it's not there, right? You do it nicely with a clear dot that is colored in, right? Okay, this one, messy, line of best, this is called the curve of best fit. When the line is not straight, you don't always force it to go on a ruler, because sometimes not all relationships are directly linear. It could be a curve, okay? So this one, your line of best fit is messy. Last one, it's unless it's set in the question to connect the dot, we do not connect the dot. But what we do is we are supposed to kind of find the general relationship. So this looks like as time is increasing, D is increasing too. And we call this the line of best fit. Like this best describes